Hi everyone, welcome to Differential Calculus. Today we explore lesson 3.3, derivatives of trigonometric functions. Number one, let's review on trig identities. First, we draw a right triangle and sketch out the angle theta. The side adjacent to the angle theta is 80J. The side opposite to the angle theta is OPP. And the hypotenuse side of the triangle is HYP. Side of the angle theta is defined to be opposite over hypotenuse. Cosine is defined to be adjacent over hypotenuse. Tangent is opposite over adjacent, which is sine over cosine. Cotangent is cosine over sine, the same as 1 over tangent. Secant of the angle theta is 1 over cosine, and cosecant of the angle theta is 1 over sine. A few more. One of the most important identity is the Pythagorean identity. The Pythagorean identity, sine square plus cosine square equal 1. From this identity, if we divide both sides by sine square theta, then we have 1 plus cotangent square equal to cosecant square. And if we divide both sides by cosine square theta instead, then we get tangent square plus 1 equal to secant square theta. Next, we have double angle formula. Sine 2 theta is 2 sine theta cosine theta. Cosine 2 theta is cosine square theta minus sine square theta. And we also have an angle reducing identity. Cosine square is half of 1 plus cosine 2 theta. Sine square is half minus cosine 2 theta. And we also have sum of the angle identity. It is useful to prove one of the derivative. Sine A plus B is sine A cosine B plus cosine A sine B. Let's move on to a review of sine cosine. The graph of sine on the interval from 0 to 2 pi look like S. Using the graph of sine, we can quickly figure out sine of pi over 2, sine of pi, sine of negative 3 pi over 2, and sine of 2 pi. For the graph of cosine on the same interval, it has a V shape. Similarly, using the graph of cosine, we can quickly compute cosine of 0, cosine of pi of 2, cosine of pi, cosine of 3 pi of 2, and cosine of 2 pi. What about the other angles, such as pi over 6, pi over 4, pi over 3? Then it is best to remember the table of values. So we have those angles, sine of the angle, cosine of the angle. A way to remember sine of the angle is we begin from 30 degrees, 45 degrees, and 60 degrees. Sine of 30 degrees of pi over 6 is root 1 over 2. And then sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. For the cosine, we flip. And what that means is cosine of 30 degree is the same as sine of 60 degree. So that is root 3 over 2. Cosine of 45 degrees is same as sine 45 degrees, root 2 over 2. Cosine of 60 degrees is the same as sine of 30 degree, which is root 1 over 2 or 1 over 2. Pretty useful table. Next part is where the sine or cosine is negative in the quadrant. In quadrant 1, sine and cosine are positive. In quadrant 2, sine is positive, cosine is negative. In quadrant 3, sine is negative, cosine is negative. In quadrant 4, sine is negative and cosine is positive. Yeah, now we are ready to move on to 3. Derivative of trigonometric function. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant square. Derivative of cotangent is negative cosecant square. Derivative of secant is secant tangent, and derivative of cosecant is cosecant cotangent. Put a negative in front. Let's prove one of them, and that is the very first derivative of sine x equal cosine x. To prove, we need to use the two theorems. Theorem number 1, limit x go to 0, sine x over x is equal to 1. Theorem number 2, limit x go to 0, cosine x minus 1 over x is equal to 0. These two theorems, we can quickly prove them using table. Do the right and the left limit and show that they approach the same number as x approaches 0. Okay, let's do first example. Prove that derivative of sine x is cosine x. Derivative of sine x, limit h go to 0, sine x plus h minus sine x over h. From here, we use the sum of two angle formula. Limit h go to 0, sine x cosine h plus cosine x sine h minus sine x over h. Split this into two parts. Limit h go to 0, sine x cosine h minus sine x over h plus cosine x sine h over h. Split the limit. Limit h go to 0, sine x cosine h minus 1 over h plus limit h go to 0, cosine x times sine h over h. The limit has nothing to do with x, so we can pull it out. Sine x times limit h go to 0, cosine h minus 1 over h plus, similarly, limit has nothing to do with x, so we can pull out the cosine x times limit h go to 0, sine h over h. Well, we use the theorem that we covered earlier. This is theorem 2, and this one is theorem 1. Using theorem 2, we have sine x multiplied to 0 plus using theorem 1, we have cosine x multiplied to 1, and therefore the derivative of sine x is cosine x. Very nice. Let's do a few more examples. Example, find f prime x. A, fx equal to sine of 2x. Before we do the derivative, we have to use double angle formula. It's 2 sine x cosine x, and now we can find the derivative. Well, this is the product of two functions. Use the product rule. 2 sine x multiplied to the derivative of cosine x plus cosine x multiplied to the derivative of 2 sine x. We have 2 sine x multiplied to negative sine x plus cosine x multiplied to 2 cosine x. What we have here is minus 2 sine square x plus 2 cosine square x. That is 2 cosine square x minus sine square x. And well, we use the double angle identity, which gives us 2 cosine of 2x. B, fx equal to cosine x over 1 minus sine x. F prime x is, well, this is the quotient. I use the quotient rules, low d high, 1 minus sine x multiplied to the derivative of cosine x minus high cosine x multiplied to the derivative of 1 minus sine x over 1 minus sine x square. 1 minus sine x multiplied to negative sine x minus cosine x multiplied to negative cosine x over 1 minus sine x square. Now we simplify this. We have a negative sine x plus sine square x plus cosine square x over 1 minus sine x square. Sine square plus cosine square is 1. So 1 minus sine x over 1 minus sine x square. And then from here, we can get rid of one factor and we have 1 over 1 minus sine x. Yay! Very cool. Pythagorean identity is very useful. 2 more examples. In C, we have fx equal to 1 minus cosine square x multiplied to 1 plus cotangent square. Well, we can FOIL and find the derivative of each one, but that is long and tedious. One of the best ways to simplify. 1 minus cosine square is sine square. 1 plus cotangent square is cosecant square. Sine square x multiplied to cosecant square is 1 over sine square x. And so this is just 1. And therefore the derivative is the derivative of 1, which is 0. D, fx equal cosecant x minus cotangent x over secant x minus 1. Best way to do this problem is to simplify the expression, because if we use the quotient rule directly, it can be pretty tedious. Cosecant x 1 over sine x, cotangent x, cosine x over sine x, secant is 1 over cosine x, and the number 1 is the same as, well, you can write cosine x over cosine x. We have a common denominator here on the top and on the bottom. So on the top we have 1 minus cosine x over sine x. On the bottom, 1 minus cosine x over cosine x. So this is the same as 1 minus cosine x over sine x multiplied to the flip of the other fraction, cosine x over 1 minus cosine x. So what we have here is cosine x over sine x, which is cotangent x. And from there, the derivative of cotangent x is negative cosecant square x. Wow, that is slick. Well, we'll have another example. Example, find all x in the interval 0 to 2 pi, where fx equals x, 2 sine x has horizontal tangents. We just have to figure out the first derivative and set it equal to 0 to solve for x. F prime x is 1 plus 2 cosine x set equal to 0. From here we see that cosine x is negative 1 over 2. So x would be, well, there are a few angles that cosine of that angle is negative 1 over 2. And according to what we have in the review earlier, the angle will be in the second and third quadrant. And it would be a multiple of pi over 3. So x would be 2 pi over 3 and 4 pi over 3. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.